All right, let's go ahead and get to part 2 here on section 9.2. So, I alluded to this in class, and this is a rough analogy. I'm not sure I want to put this in front of other math professionals, but all being the same, there are two ways that you can, not two ways, there are multiple ways you can measure the exact same distance, and you guys know this. Um, we can go describe a very popular road race as 3.1 miles, or we can describe it as 5 kilometers, a 5K. They both mean the exact same distance, they're just different labels, measurements, units of measure. The one thing I think you can appreciate is that if you try to do a miles calculation with numbers that are kilometers or vice versa, stuff can get uh, screwed up in a hurry. So, the reason I tell you that is because now we're going to talk about measuring angles, and up to this point in your life, you've done nothing but degrees. But there is another way to measure angles, and these are called radians. Roughly speaking, what happens here, or the idea here, is the circumference of a circle is found by the formula 2 pi r. And again, this is rough. I'm not sure I'm putting this in front of my fellow math professionals, but say there are 360 degrees when you've traveled the full circumference of a circle, even though you don't know the radius, right? If we start to divide the 2 pi r off, get r by itself, we have 360 equals, or 360 over 2 pi equals r, which is 180 over pi equals r. So in radians, really, this is our thing, and I know this seems really weird, but it's something we'll go with. So radians have two different things going on. Because it's just a ratio, we're going to end up using one of two conversion units down below, and you'll see how. But we either use 180 over pi, or we use pi over 180, depending on what direction we want to go. Meaning, if we want to change something from radians to degrees, we'll use this one. If we want to go from degrees to radians, we'll use this one. Furthermore, you're also, and we alluded to this in the last section, at least in class, but you're going to want to always check your calculator for the mode that it's in, whether it's degrees. So you'll be able to look in the mode button, and it's going to tell you whether your calculator is in degrees or radians. Again, if you have your calculator set wrong, um, it'll be using the wrong units of measure all the way through. So let's do something real quick just for a unit circle, just in general. So there's 0 degrees, right? There's 90 degrees. Well, let's travel counterclockwise around uh, this kind of thing. So if that's in degrees, right? And we use blue. Imagine we go all the way around the circle. That whole circumference then is 2 pi. So the equivalent measure in radians to 0/360 is 2 pi. All right. Now imagine we wanted to go half a circle. So we take our 2 pi and we divide it by 2. So 180 degrees is the same as pi radians. Now imagine this semicircle, we want to divide it into, again, so instead of just pi to 180, we'd have pi over 2. and pi over 2 radians is equal to 90 degrees. We can take another pi over 2 because we know that's 90, and 90 getting from 180 to 270. So pi plus pi over 2 is 3 pi over 2. And these are kind of some reference, like common knowledge right off the top of your head. So when we're talking 2 pi in radians, we also know it's equal to 360 degrees. When we're talking 3 pi over 2 radians, we know that you're also talking 270 degrees, so on and so forth. It's just how these measurements compare. But let's get into some of the other math. If I want to convert degrees to radians, here's the conversion we set up. We take 120 over 1 times pi over 180. And then what we want to do is simplify as much as possible. Divide by 6 is 2 pi. Divide by 6 is 3. So by doing a simple conversion, we know that 120 degrees and 2 pi over 3 would be the exact same angle size. No, at minimum I can divide it by 5. I might have to go farther, but I'm going to try this first. Yep, I can go farther. Divide by 9 now, and I get 3 pi over 4. So this and this measure the exact same size angle, just one's in a degrees measure and one's in a radians measure. First of all, if we go negative 40 over 1 and then pi over 180, we can start there. And then divide by 2 is negative 2 pi over 9. Since we're not talking coterminal angles yet or anything like that, or standard positions, I'm not going to worry about the negatives. So negative 2 pi over 9. And then finally, negative 150 over 1. If I divide this by 3, I get negative 5 pi. Divide this by 3 over 6. So that's the start of radians. All right, so now we're going to go from radians to degrees. I want to remember that this is now we're going to use the reverse. And the way I've always remembered it off the top of my head is I want to be able to cancel this pi in this original problem. We don't really have pi's in our degree measures. So now I know that the 180 goes on top and the pi goes on bottom. What that allows me to do is go like this, and then what is 180 divided by 12, y'all? 15. So we got that negative. So really what we're saying is negative 15 degrees and negative pi over 12 are the same size angle. 5 pi over 4, 80 over pi, divide top and bottom by 4. 4 by 4, I get 45 times by 5, 225 degrees. So this and this are measuring the same size angle. Pi on ahead, 9 pi over 4, 80 over pi. Divide by 4, divide by 4 is 45. 45 times 9. Big ol' angle here, 405 degrees. I'd say obviously it's more common for us because of how we grew up, being able to picture picture angle sizes by degrees. So what I'm going to do is take this, I divided it, a pi out of it, factored a pi out of it, because then I get to write it like this, which seems really silly, but -2 times pi is that decimal. So then when I want to do this, the numbers just work out a little bit better, which conveniently I should know it's -360 from the work we did up in the notes. But either way. So some of this whole section, excuse me, is purely to make sure that you're using your calculator correctly. So again, hit the mode button, and then where you have a choice between degrees and radians, we want to make sure we've selected, highlighted, whatever you call it, radians. We're going to go mode, make sure I'm in radians. So these first two I can just do and just type in cosine, fraction, 4 pi over 3, and I'll get -0.5. So again, it's just making sure you can type these in correctly. So please try it. Be in a world of hurt if we can't make a calculator bend to our will. Okay, now cosecant, right, is the inverse of sine. So if you imagine, right, again, if you imagine an angle here, right, and inverse of sine. So if sine is opposite over hypotenuse, then this is hypotenuse over opposite. Imagine we know that this is 10 pi and this is 11. All of a sudden, if we don't have a cosecant button on our calculator. So what I'm going to do is, instead of typing in this problem, I'm going to type in sine of 11 over 10 pi, and it should be equivalent. So sine same idea over here. TOA is opposite over adjacent, so cotan is adjacent over opposite. So if we know that adjacent is -6 pi, opposite is 5, then equivalently we should be able to do tan of 5 over -6 pi and get the exact same thing as cotangent of that. And get -0.2717-ish with a little bit of rounding in there. All right. Now, last part's kind of a geometry thing. I did not, so you got notes for, or a box for some notes. Here's the notes, right? I'm not writing all this out all the way. All right, so let's see what some of this does. It says find the length of the outfield fence and the area of the field. So the outfield fence would be, this is what we know commonly called as a sector. It's just a portion of a circle. So because we're given 90 degrees, let's go ahead and work with the degree portion of our arc length. So let's work with this one. So 90 over 360 times 2 pi radius of 200 foot. The reason we know that's a radius of 200 foot, imagine us continuing out into a circle. So type in my calculator. I actually get 100 pi is my length. I think I'll just leave it as that. You can take it out to the decimal if you want. And then area of the sector, again, it's still measured in degrees, so we're going to use the degree formula. Times pi 200 squared. While I'm typing this in the calculator, I do want you to know that I won't make you memorize these formulas. I just want you to be able to crank them. So, do with that what you will. I get 10,000 pi. And I guess we could write this thing could be feet because of feet. And this could be feet squared because we're doing area. But neither here nor there. Go ahead and get into the textbook problems. Hopefully most of this is right up your alley. Let's roll.